A continuous random variable x has a probability density function f given by f of x is equal to the following piecewise function: kx for x between 0 and k, 2kx minus x squared for x between k and 2k, 0 otherwise where k is greater than 0. Letter A, show that k satisfies the equation 7k cubed is equal to 6. Here, we need to use the fact that the area under the curve must be equal to 1. So the integral of the function needs to be equal to 1 in the interval being considered. We have to write that the integral from 0 to k of kx dx plus the integral from k to 2k of 2kx minus x squared dx, this needs to be equal to 1. Then we have to evaluate both integrals. The integral of kx is kx squared over 2 from 0 to k, plus the integral of 2kx is 2kx squared over 2 minus x cubed over 3 from k to 2k. This sum must be equal to 1. Here we can cancel out these 2's, and then we can now plug in the values, lower and upper limits. First, k times k squared over 2 minus k times 0 squared over 2 plus k times 2k squared minus 2k cubed over 3 minus k times k squared minus k cubed over 3. This must be equal to 1. This part is equal to 0. Let's simplify the expression k cubed over 2 plus this part is equal to 4k squared. When it multiplies by k, 4k cubed. So 4k cubed minus, this is equal to 8k cubed because 2 cubed is 8. So minus 8k cubed over 3 minus, this part is k cubed, so minus k cubed, then plus k cubed over 3. This needs to be equal to 1. Now we have to combine the terms. 4k cubed minus k cubed, 3k cubed. Now adding these terms is going to be minus plus k cubed over 2 minus 7k cubed over 3. This needs to be equal to 1. To get rid of these denominators, we can multiply the whole equation by 6. If we multiply all the terms by 6, we get 18k cubed plus 3k cubed minus, when you multiply this by 6, it becomes 14k cubed. This is equal to 6. 18 plus 3 is 21k cubed minus 14k cubed. This is equal to 6. Then finally, 7k cubed is equal to 6. For part B, we need to find the median of x. Then it will help if we have a sketch of the graph of the function f. Starting with kx. Kx is a straight line with gradient k. So it goes from the origin up to a certain point here, k. The value of the function here is k times k, which is k squared. So that's the first part. The second part, 2kx minus x squared. It's a quadratic, concave down, with roots that are not so difficult to be found. If we make x a common factor, we are left with this equation that has roots, x equals 0 and x equals to 2k. So the quadratic, it's concave down. It starts from the origin. It has two roots at 0 and 2k. So the maximum is at k. And then we can sketch this graph, drawing a quadratic here, but for the domain required, it's only this part. So we have a function that has this shape, and we want to find the median. We want to find the value for which the area under the curve is 0.5, the middle. Then we would need to know what is the area, what is this area first, to know if it's more, it's greater than or less than 0.5. Then to do this, we need to find what is the value of k. 7k cubed is equal to 6. K cubed is equal to 6 over 7. K is the cube root of 6 over 7. We need to know the area. What is the area of this region? By using an integral and by substituting k for cube root of 6 over 7. We want to find what is the integral from 0 to k of kx dx using this value of k. We can use our calculator, and then we find what is the cube root of 6/7. Let's calculate this. What's the cube root of 6 over 7? Then, to make it easier to work, I will store this value in the variable k. So from now on, k is this value. And then now I can get the calculator to find the integral using k. So the integral from 0 to k, so alpha k. Then again, kx dx. Let's see if this value is greater than or less than 0.5. It's less than 0.5. If we want to find this value as a fraction, then we use this option to convert the number to a fraction, 3/7. So what we have, in fact, is that this region has an area of 3/7. So which is less than 0.5. So the median is somewhere here. It's a value m. Then we want to know what is the value m such that the integral from k to m of 2kx minus x squared dx is equal to the value that we need, that is half minus 3/7. So we can use our calculator to find half minus 3/7, or just use fractional ideas, like this is 7/14 minus 6/14. This is 1/14. So what we need to do is to solve this equation. What is the integral from k to m of 2kx minus x squared dx? This has to be equal to 1/14. There are some ways this can be done. So we can get the calculator to graph this, and then we will be able to find what is this value m. So we come here and then we insert the integral using option 9, the integral from k, alpha k, to a certain value x that we want to find of 2k alpha k x minus x squared dx. And then we want this to be equal to 1/14. This value k is about close to 1. So we are going to use a window that goes from 0 to 1 in the x-axis, maybe from 0 to 0.3 more or less on the y-axis. If it's not a good window, then we may change. Let's see if we can find the point of intersection of the function, which is the integral, and the line 1/14. It may take a while for the calculator to do it. So not the proper window. So we can increase here to 2, and then it will probably be enough for us to see the point of intersection. And then after we see the point of intersection, we can use the option intersect to find the value that we want to find. So now we go to second calc, select intersect, and then press enter 3 times to find the value with this, which is 1.029, 1.029, m is equal to 1.029, which rounds to 1.03 to 3 significant figures. We're going to do the same in Casio calculator. First, let's find what's the cube root of 6/7. This is equal to this number. And we're going to store by pressing this arrow and then using a letter such as K. So we press to get the letter K alpha, and then the key where is the K, the letter K here, comma. So from now on in this calculator, K is 0.9499 and so on. We go to menu graph, and then whatever is here, we delete. We are gonna insert the integral. The integral is, to get integral, you have to press option, calc, and then we select integral. We are gonna integrate from K, so we press alpha, and then K, up to a value X of the function 2K X minus X squared. In Y2, we are gonna include 1/14. And then we are going to graph this in a window that is appropriate for this. So if we go to window from 0 to 2, and in Y from, let's say, -1 to 1, let's see what we get. That's our integral, then the line y plus 14. So it's enough to find the intersection, going to G-solve, intersect, and then it takes a while, but the calculator will show the value 1.029, same value we found using TI-84. Here in Nspire, we first calculate cube roots of 6/7, pressing Control, and then we insert 3 here, 6/7, enter. To store it, we have here the key store on top of var. So Control, store, and then we select K, that's our letter, K, and then from now on, K is this value. Then we insert the integral by pressing this book and then selecting numerical integral. Here we're going to use K by pressing K. And notice that this K is in bold. And here on top, we need to put X. And then in the integrand, we're going to put 2KX. But here we have to put 2 times KX so that the calculator recognizes this as a number, KX minus X squared dx. I have dx. Then if we want to look at this closely, then we can change this value to -1, for example. Can change this -1, and here to 1 or to 2. And then what we want to do now is to graph another function, which is 1/14th, and see the intersection with this line. To get a better view, we can change this to -0.2, 0.2, and here 0.2. So we are going to find the point of intersection by going here and then selecting Analyze Graph Intersection. And then we need to find the second graph, which is this one. And then we give the boundaries, lower bound, upper bound. And that's the answer we're looking for, 1.03, just like in the other calculators.